Yeah, so we'll be looking at approximation and estimation. We don't really have to find the exact figure, but we are looking for the number that is next to it, or that is closer to the actual number. We're just estimating. Yeah. So within the estimation, there are quite a few components that we'll be looking at. And the first one is called significant figures. How do we know if a given number is considered as a significant figure? Now, when you say a significant figure, what are we talking about? We're talking about figures or numbers or digits that are known with certainties, with some sureties. Now, what does that part mean? Let me try to explain. This part here, what does it mean? Talking about a number with some certainties. When someone asks you, how old are you? And then you say, I'm 2 years, 4. I'm 4 years old. Someone is very sure that the age you have is 4 years. Very sure. We have a fixed figure. Now, when someone says, according to this topic, when someone says, I am 40 years, it means we are only sure about the 4. It means we are only sure about the 4, because remember, if you say these are 10s and these are 1s, we are sure of the 10s. How many 10s are they? There are 4 10s. But do we know how many 1s are they? There's a 0 there. So it becomes difficult for one to be sure of how many 1s are there. That's why you find that when you have a 40 and they ask you to write this, how many significant figures, we're just going to say that the number of significant figures is just 1. Because in the number 40, if you are to write the way I've explained, let's say these are 10s and these are 1s, how many 10s are they? They are 4. And how many 1s? Nobody knows. There's a 0. So like that, you can say there's only one number that is giving us some significant, some sureties, some certainties. So we find that in the number 40, they ask you how many significant figures are there. There is only 1. So that is the thing. Now, we are saying that when you're doing the number of significant figures, there are quite a number of rules that we follow. So each step of the way, I'll be asking you, like wherever I reach, I ask you to write. When you're done copying, I go to the next stage, just like that, just like that. So let me know when you're done copying from this part, okay? Are you okay with what I said? Someone is done. Who is still writing?
Me.
Okay, you let us know when you're done writing.
I'm done.
Okay, others?
Done.
Are we all done? Are we all done? I want you guys to be responding. I want you guys to be responding. To be difficult for me to know who is done and who is not. Then, so we're saying that there are 3 rules that we follow when you are determining how many significant figures are in a given number. How many significant figures are in a given number. So we're saying there are 3 rules that we follow. And the first one, we're talking about having the non-zeros. Now, you see, there are 2 types of numbers. There's a 0 and a non-zero. So we are saying that when you have all the non-zeros in a number are considered to be significant. All the non-zeros are considered to be significant. And the thing that we have is right over here. So we are saying that in the first part, we're saying that all the non-zeros are considered to be significant. So we have this digit here, which is 731,000. Now we are saying that regardless of where that non-zero digit is placed, the truth of the matter is that that number is considered significant. No matter where that number is positioned, the truth of the matter is that the number which is not a 0, those numbers which are called non-zero digits are all significant. So in here, these zeros that we have here are not important. These numbers here are not significant. So the only significant figures that we have here is 3. What numbers are they? 7 here, 3 here, as well as a 1 here. So there are 3 significant figures in that number, 731,000. So in there, we have 3 significant figures. And when we go to the second point is talking about having zeros within a number, and those zeros are written at the end. So, okay, before we go to that, in here we are saying that the non-zeros, regardless of where they are considered to be significant. And if you have zeros at the end, these we call them trailing zeros. Trailing zeros are not significant. The zeros that are at the end of a number after the non-zero. So you can see that this one here is a non-zero, and then all the numbers that come thereafter, all the zeros, regardless of how many they are. You can have 10 million. You can have 10 million. 1, 2, 3, 1, 2, 3. In that 10 million, the number of significant figures you have is only 1. That's what it means. The trailing zeros, those zeros after the non-zero are not significant. So in there, you can see that the number of significant figures that are there is only 1. Now, when you go to this part where you have zeros that are written within the non-zero digits. You have zeros that are written within non-zero digits. So let's say you have this number here, 700 and 700,200. 700,200. In there, these zeros that are within the non-zero, these zeros here are considered to be significant. That's what the point is trying to say. That any zero written between the non-zero digits are significant. So combining the first concept and the second one, with the first one we said all the non-zero digits are significant. So we're going to say that these two are for sure significant. And then these two zeros that are in between are also significant. Therefore, the total number of significant figures are 4. The total number of significant figures are 4. Therefore, these zeros that are at the end, trailing zeros, are not significant. So the number of significant figures in there are 4.
Sir.
Yes, Suwilanji.
So you said there are the non-numbers that are within the zeros are considered to be significant figures.
I didn't say that. I said zeros that are written within non-zeros.
Oh, so sir, like how about the way it is at 700, then the way it is here 200? How do you know that these are trailing zeros?
We're talking about zeros that are at the end of a non-zero. This 2 is not a zero, so therefore all the zeros that are following there are not significant.
Oh, all right, sir.
Any other question?
No.
Okay, so that's what it means. So in there we can say that there are 4 significant figures. Now, what if I'm to give you this number here? If I'm to give you this number here, and the number is 2, 0, 0, okay, 2001. How many significant figures are there? 4.
1.
4. Someone says 1. Others, what are we saying? Chuma, how many significant figures are in here?
Yes. I think it's 4.
Okay, Ndeke, how many are they?
4.
How
4,
many?
sir.
Peso, how many are they?
Yeah, 4.
There are 4. Exactly. Exactly. There are 4 because we have these ones that are non-zeros. We have these ones that are non-zeros. And we said no matter what, these guys are significant. So we can say that 2 here is significant, that is 1. This one is also significant, that is 2. And then the point is from emphasizing that the numbers that are written in between the non-zeros are also considered to be significant. And because of that, we have 4 significant figures.
Sure.
So we learned, my dear.
How about if it's 0, 1, 0, 2?
0, 1, 0, 2. Okay, before we even go to that, do you know that there are some people who like numbering as 0, 1, 0, 2? You've never seen them like that?
Yes.
From here, what are the numbers? The numbers that we just consider are these ones here. So the leading zeros are not significant. Unless you say 0.0, that one, it makes sense. But for as long as these leading zeros, the zeros that are at the beginning, my friend, those ones are not significant. So because of that, the only clue we can get from here is that in this number, how many significant figures can we get? How many can we get?
3.
3.
Uh-huh. Yeah. So that is what we're supposed to do. Have I answered your question?
Yes.
So that's what we're going to do. Then we go to the next point. The next point says, which is the last one. The last one says that only the zeros that are at the end of a decimal number are significant. So we're saying that only the zeros that are at the end of the decimal number are significant. Only on the zeros that are at the end of the decimal number are significant. So let's say you have 0.1000. For as long as these zeros are coming after the decimal point, those numbers are considered to be significant. Saying that the zeros that are at the end of the decimal number, those ones are considered to be significant. Are we okay?
Yes.
So let us see if we can go to the next slide. Okay, this one here. Let us see.
Sir. Sir, I have a question.
Bring it over.
So how about if it was 4.031?
That is the question, 4.031. How many significant factors are there? You guys, what do we say? How many significant figures are there? How many significant figures are there? How do we say? In here, my friend. In here, my friend. Look here, for as long as this number is a non-zero, for as long as this number is a non-zero, we are going to count it 1. Plus, you see that this is 0 here also is between the non-zeros, so it must be significant. For as long as this number is between the non-zeros, it's also significant. Therefore, these guys are also non-zeros, they're significant. So in short, we're going to say 4 plus 3, the number of significant figures are 4. So Wilanji, I answered your question?
Yes.
Yes, so that is the way to go about it. Then let's see that point we're trying to exhaust, that the numbers, that the zeros that come after the decimal point are significant. So if we say that way, so we are going to say that in here, these ones, because they are leading zeros, these leading zeros are not significant. Therefore, the significant figures that we have are only 2. Now, when we say that the zeros that come after the decimal point, we are talking about having a number like 0.1, 0, 0, all these zeros, the trailing zeros that will come after the decimal point, we are going to say that they are significant. We are going to say that they are significant. But if you have 0. Like the one we have 0.0052, these numbers are trailing zeros or they are leading zeros. These numbers, these zeros, these digits are leading zeros. So therefore, they are not significant. And as a result, we only get to have 2 numbers that are significant in this thing here. I do not know if I've explained it in the best way.
Yes.
Now, what about in here? This is another scenario. What about in there? We're saying that 0.200 in there, these trailing zeros this time around, because they are coming after the decimal point, these zeros are significant. Therefore, we can say that the number of significant figures in there are 3. We can say that the number of significant figures in that are 3. And then we have examples, right? Over here, we have examples. The examples are saying, find the number of significant figures in each of these numbers there. Find the number of, let me just zoom out a little bit so that you'll be able to write in the best way. Find the number of significant figures that are in that number there. Yes, so we are going to answer that together. How many significant figures are in there? Maybe I'll allow you to copy the questions down. You guys, have you written down the question?
Yes.
Yes.
Okay, someone is trying to join. Then, okay, finally, Hope joins. For Hope Katongo Shula joins, and good to have you. Though we are just concluding the first part of the 40 minutes that we've had, and I'm sure I'll send you the recording as soon as the conversation is done, so that you get reminded of the things that we've just done. So we're trying to look at the number of significant figures. So the question says, find the number of significant figures in each of the following. So the first question that we have is right over here. The first question is 40800. Now in there, we're going to follow the first step as well as the second step, or the first rule as well as the second rule, because the first rule was talking about the trailing zeros. The trailing zeros are not significant. The trailing zeros are not significant. So we can say that from here, these 3 zeros are not significant. So aya, among the significant figures, it is we got to remove these 2. That is the first rule. Then the second rule was guiding us that the zeros that are written between the non-zeros, the non-zeros are any number other than 0. So in here we have 4 and 8, and between 4 and 8 we have a 0. So because this 0 is written in between, therefore we are going to consider it among the significant figures. So as a result, in here we have 3 significant figures, and these significant figures are 4, 0, and 8. These are the only significant figures that we have in that number. I hope we understand.
Yes.
Okay, then we can go to the next one. The next one is talking about this thing here. This thing here is purely coming from the third rule. The third rule was saying that the trailing zeros that are written after the decimal point are significant. The trailing zeros that are written after the decimal point are significant, whether they are between the non-zeros or they are just written at the end, like the way we have that, zero at the end. We're going to call it, we're going to say that is significant. So first, let me remove this so that people should not just be looking at these answers, but they should understand where the answers are coming from. So this one here, we have 0.20010. So one thing that we need to know for sure is that this is 0 at the end. For as long as it is coming after the decimal point, we are going to declare it significant. And above all, these 2 zeros that are between the non-zeros 2 and 1, these ones are also significant. As a result, we can say that all these digits that are written after the decimal point are significant. We can count them. How many are they? We have 1 here, we have 2 here, we have 3 here, 4 here, 5. So in that number, we can say that there are 5 significant figures. We can say that there are 5 significant figures, and which figures are they? We are talking about these ones here. They are all significant for as long as these zeros are coming after the decimal place. And again, in a situation whereby you have leading zeros that come after the decimal place, like 0.001, in here, these leading zeros, even if they are after the decimal place, for a decimal point, for as long as they are leading the non-zeros, we are not going to declare them significant. We're just going to say that the significant figures in here is 1. Okay, so we can go to the other one here. This one is purely coming from the second rule, which is guiding us that the zeros that are written between the non-zeros, what do we say? Are they significant or they are not significant? What are we going to say about them? We are going to say that they are significant. So in short, all these numbers that are in here are all significant. And once we count them, they are gone before. So we have 4 significant figures. This one is the same as this number, which is here, because we have the zeros that are written before the non-zeros. So even those numbers are going to be considered as significant. So we just go and count them. So there's 1, 2, 3, 4, 5, 6. So 6 of them are all significant. Are all significant. Now, what about the last one? What can we say? How many significant figures are there? We can see that these numbers that are written here, these zeros that are written here, are written before the non-zeros. They are written before the non-zeros, which are 8 as well as 2. So because they are written before the non-zeros, we're going to declare them significant. That number and that number are the ones that are having these zeros in between. So as a result, we're going to say that they are also significant. We just need to count them all, and then we're going to say that there are 5 significant figures. Any questions so far? Because we are running out of time in the